Soundproofing a ceiling is usually required because there are loud impact noises in a room above, like footsteps, or because your room is disturbing a space above you with airborne noises like talking or music. Many people ask, when it comes to installing ceiling soundproofing, can you add it over the top of the existing surface? Well, you can, but it is not the best method. Firstly, your soundproofing won't be half as good. Secondly, it will cost you more as you need to add wood battens to your ceiling. And thirdly, it will take up considerably more headspace. For all those reasons, we always tell people to take down the ceiling before soundproofing. Coving certainly needs to be removed, and it can be reinstated after soundproofing, but only if a few simple rules are followed, and we'll look at those later on. So let's make a start. Just as with any renovation or home improvement job, there is a little bit of prep to complete first. If you're doing this whole job as a DIY project, then you might want to have an extra pair of hands on site with you and look at hiring a plasterboard lift because it's the easiest and safest way to install our soundproofing boards. Just as we have already said, your current ceiling surface needs to be removed, as well as the coving. If you have a light fixing, a pendant light is preferred for soundproofing jobs because it will only make one small hole in your ceiling. If you have downlights, consider having these changed for a single pendant fixing because spotlights will create many holes in your new ceiling. When the ceiling is down, which shouldn't take too long, you'll have exposed the wooden joists. The cavity space inside will either be empty or have fiberglass insulation in it. This insulation needs to be removed because it won't have acoustic properties, only thermal. To have acoustic properties, the insulation must have a high mass, and thermal insulation doesn't have this. Now, the reason this is important is that spaces between the joists can create a drum effect. Just like a drum, when a noise gets into this open space, it will bounce around from surface to surface and get louder. In effect, the original noise issue from above is made even worse by this cavity space. However, by installing acoustic grade mineral wool, we slow down the reverberation of noise and stop this from happening. You go from an echoing chamber to a space that sounds like a warm room filled with soft furnishings. Ultimately, the noise you're blocking is quieter and your sound blocking layers don't have to work quite as hard. The acoustic mineral wool should fill around 70% of the available cavity space. Don't fill it all the way because this can cause damp. Acoustic mineral wool is very dense and won't need to be supported to hold it in place. Instead, cut the insulation slightly wider than your cavity and it will fit snugly in. Acoustic mineral wool is very easy to cut with a serrated knife. To make your life even easier, you can cut the mineral wool to size while the slabs are all together in the packaging with a saw. Because this is a fibrous material, you should wear gloves and a mask while handling the slabs. Please also remember to wear goggles, especially when you're installing this into a ceiling. Now that the cavity space has been treated and you'll no longer experience the drum effect, you can start to install the all-important mute clip frame. Remember that this is the shock-absorbing layer and it's going to give you a floating ceiling layer and block the most noise. Something that is worth mentioning here is that you aren't constrained to our classic mute clip. We actually have a few different designs that can help you to accommodate different ceilings. For most people, the regular mute clip is perfect, but if you're short on headspace, you might want to look at the LP system. This is a low-profile option that sits inside the cavity space and will give you much more headroom. This option is amazing as it only loses you 39mm of headspace after your soundproofing panels have been added. This is over 20mm less than other slimline isolation clip designs. If you need to go the other way and increase the ceiling drop to make room for pipes or wires, then we also have a clip for that. The XP is an extended profile and can give you extra space to hide away your fixings. When it comes to fixing your clips, you should follow our diamond formation because this will spread the load evenly over all of your joists. It's easiest to mark out your rows with a chalk line, and because we have a single point fixing, you only need one marking per row, which makes our system much simpler and faster to install than some of the others. Mute clips around the perimeter of the ceiling need to be no more than 100mm away from the adjacent walls. The rows of mute clips will go across your ceiling joists to give you a crosshatch effect. You should space the rows up to 400mm apart. To create our diamond layout, alternate the second mute clip position between 400 and 800mm away from the first fixing, row on row. This will give you the staggered layout that you can see here. Thereafter, space the clips up to 800mm away from each other. Because most ceilings will not perfectly divide into these numbers, it's totally normal for the penultimate clip to be closer to the final fixing than 400mm, and this is absolutely fine. When you are ready to screw the clips into place, use 5x60mm wood screws. We have all of the fixings written down for you in the installation guide, which is linked below to make your life simpler. A top tip here is that the clips should not be over tightened. You should actually be able to gently twist the clip from side to side a little. This prevents rigidity and ensures that your decoupling system can work as a shock absorber. It will also make the installation even easier because unlike a dual clip fixing system where the clips have to be fitted perfectly parallel, our mute clips can be straightened up as you go so that the channel is easy to fit. The fairing channels come in lengths of 1.5 meters and can be cut shorter easily when needed. This can be done with a pair of tin snips or a junior hacksaw, whichever you prefer. If the channels are too short, then they can be easily overlapped like so and fixed together with 4 20mm steel self-tapping screws, 2 into each shoulder. The channels need to overlap each other by 200mm for a secure fit, and be sure that this isn't over a mute clip because it will be too thick to fit properly into the mute clip claw. An important note here is that the channels should not make contact with the adjacent walls. Instead, leave a 2 to 5mm gap at the edges. If they made direct contact, it would short circuit the system and encourage sound vibrations to get into the new partition. The aim of the system is to isolate it from the original structure as much as we can, so watch out for these simple details when you're installing. While you're up the ladder, take a pencil and make a mark on the wall for the centre of each channel. This will help you later on after the first layer has been installed, and you'll be able to find where the channels are and get the second layer screwed into place. When your channels are in securely, we're ready to add the layers of soundproofing to your ceiling. The first layer is acoustic plasterboard. This is heavier than regular plasterboard because the increased mass makes it better for blocking sound. Be sure that the boards don't make contact with the walls around the perimeter of the ceiling. This will create a sound transmission pathway. To make it easier for you, use some packers to keep the panels away from the walls while they're being fitted. Measure your ceiling and calculate how many panels you think you'll need. If you find that the last part will be a small slither of plasterboard, then you'll want to cut the penultimate piece smaller. This will allow you to fit 2 slightly smaller panels instead of one tiny piece that will be hard to secure and create a weak area. To screw your first layer of boarding to the wooden joists, use a 32mm fine thread drywall screw. We'll be using different screws for the final layer, so make sure you pick up the correct ones. As you go, remember to pull through your cables for lighting by making a small hole. Around the wire, you can seal the hole with acoustic sealant. If you have downlights, then you'll need much bigger holes, of course, but you can also use acoustic covers. These are not as good as simply making smaller holes for a pendant light, however they do offer a little more protection against noise travelling through the light fittings. Before the first layer is completed, we need to seal up the gaps. Soundproofing is just like making something airtight, so small cracks and gaps do make a difference. Run sealant around the perimeter into the gap that we left there and over the joins between your boards. You can now mark your new chalk lines using the pencil guides that you marked on the walls at the beginning. Now, the second layer is not a rigid board, but a heavy viscoelastic membrane. This membrane gives more mass and also reduces the rigidity of your system so that it can better reflect vibrations. Using materials with different levels of high mass is beneficial to soundproofing because you'll actually get diminishing returns from repeating the same material too many times. The very best method for getting the viscoelastic membrane onto your ceiling is to adhere it to the last layer of plasterboard before it's screwed onto the ceiling. Bond the viscoelastic membrane to the back of the boards and be sure to push air bubbles out as you go. Membranes are easily cut with a sharp blade and trim them to the edges of your boards for a flush finish. The second layer of plasterboard should be staggered to create a stronger system. Just like a brick wall isn't built with each layer sat directly over the first, but instead with the layers offset by half a brick each time, we also need to offset our second layer. This will mean that the joins between the panels won't match up and we strengthen the whole system. Use the plasterboard lift to position the boards in place and once again create a 2 to 5mm gap around the perimeter. This layer will require 50mm fine thread drywall screws to go through 3 layers and secure to the joist. Again, once this layer is in place, you can fill the gaps and cracks with acoustic sealant for an airtight finish. Over the joins between the panels, run scrim tape. This will offer good purchase for your skim plaster layer. If you're wanting to keep your coving, then you'll need to be very careful about how it's installed. The best scenario is just not to reinstate it, but we do understand that some people may want to retain this feature. What you need to do is either fix it to the ceiling or to the wall, but not to both. So let's say you fix it to the wall. You'll need to leave a gap of a few millimeters from the ceiling so that they don't touch or we end up with a rigid join between your once suspended ceiling and the wall. You might have guessed it, but the gap will be filled with acoustic sealant. Now, I've mentioned this sealant a lot throughout, and you might be wondering if a standard cork would also work. However, it won't, so don't substitute the materials out in this way. Acoustic sealant doesn't have a rigid solid set. Instead, it has a flexible nature that works similar to our viscoelastic membrane by dissipating vibrations. So there you have it. A whole ceiling soundproofing system from start to finish. If you want any guidance in choosing the right system for your situation, then do have a look at our other ceiling soundproofing videos coming up next, or reach out to our helpful technical team. We're always on hand to get you the best results. For more information, head over to iKoustic.co.uk.